Sound is a kind of wave. It is used to transfer energy from a vibrating body to an ear. For a sound to complete, there should be a vibrating body, a medium, and a receiver. Okay. A receiver, in most of the time, it is an ear of a human being or any other animal, or it can be a microphone. So sound completes with three things. Number one, a vibrating body, medium, and a receiver. So in this case, you can see this is an ear. So this is a speaker. Speaker cone vibrate. And look, this is air in room with no sound. Okay. Not very easy to produce a room with no sound in it. But if we have a room with no sound, all of the molecules will be equally spaced. These are the layers of molecules at any instant. Now, what happens when we start the speaker? So when speaker pushes forward, the air molecules get closer to one another, producing a compression. And when the cone of the speaker goes back, it produces a partial vacuum, a region of less air molecules. So when speaker goes forward, it produces a compression, and when it comes back, it is pulled back, it produces a rarefaction. So compression and rarefaction and compression and rarefaction, they are produced one after the other, and they go in 3 dimensions away from the source. Like compressions and rarefactions are concentric balloons. Compression is a balloon, rarefaction is a balloon that follows the compression, another compression follows the rarefaction, and another rarefaction follows the compression. So they expand, these balloons of compression and rarefaction, they expand away from the source. Now, this is a diagram. When speaker is turned on, at any particular instant, we can have compressions and rarefactions at particular instant. Now, the center of compression to the center of compression from center of compression to center of compression is lambda, or from center of rarefaction to center of rarefaction is also lambda. Okay. So lambda, which is wavelength, can be from the center of rarefaction to the center of rarefaction, or center of compression to the center of compression. Speaker is a vibrating source. There are several compressions and rarefactions produced. What is the specialty of compression? Compression is a region of high pressure, high density part of the fluid. Rarefaction is a region of low density pressure and larger intermolecular spaces part of the fluid. So this kind of disturbance is produced in the air, so the sound can travel from the speaker to the ear. Now, quality of sound, things affect sound. Amplitude of the sound and frequency of the sound. Look, there are 3 sounds over here. Okay. Sound 1 is a normal sound. Sound 2 is a louder sound. If I have to be louder, For example, right now, I'm trying to speak loud as possible. I don't know whether you hear it loud or not, but I'm producing a louder sound. So what I do is I put more energy into when I'm speaking. So more amplitude. It is the same frequency, same voice. Only difference is it is louder because it has more amplitude. Look at the last sound. It is same frequency, but this one is a quieter sound. It is the one that is very faint. It is like a whisper. Okay. So when we say that we have to increase the loudness, which is in everyday life, we call it volume. For example, if you want to increase the volume of television, actually you want to increase the amplitude of the vibration over there. You just want to make the amplitude of the vibration a bit larger. So you need to understand, this is where the examiner is very good at. He wants to know whether student understands this or not. That amplitude affects loudness. Make a note about it. Amplitude of sound affects loudness of sound. Now, another thing is pitch of the sound. Look, three waves are there. The first one is a normal pitch. Second one is high pitch, because in the same time, more number of waves are produced. In the same amount of time, more waves are produced. So this means it is high pitch. Some people have high pitch voice. For example, can you find difference in this sound and the previous sound? How do you think this sound is different from the previous one?
It is different.
How is this different? Like, what is different about this one than this one? I am only changing frequency. I'm making, like, to do that, all I have to do is just tighten my voice cords and they will produce more frequency. And the sound will become more shrill, more high pitch. Okay. I can speak this way. How do you think this sound is different from a normal sound? How do you think this one is different from the normal
Has
one?
a high
Again,
pitch.
this is low pitch, actually. This one is low pitch. This voice is low pitch. This voice is high pitch. And this is my normal pitch. So pitch means frequency. If you increase frequency, you will have high pitch. Frequency and pitch, you can connect them with one another. Pitch is same as frequency. Okay, what else decreases when pitch increases? Look at the second diagram. You will find out when you increase pitch, wavelength of the sound also decreases. When pitch of sound increases, wavelength of sound must decrease, vice versa. Like if you increase the pitch, wavelength decreases. So if you decrease the pitch, wavelength will increase. So I hope you understand that the quality of sound in O levels will mean the loudness of sound, how loud a sound is, and what it depends on. It depends on frequency, amplitude of the sound. And second thing is Pitch of the sound. Pitch of the sound depends on frequency of the sound. High frequency, high pitch, low frequency, low pitch. Okay. Now, audibility range. Human can only hear a minimum frequency of 20 hertz and a maximum frequency of 20,000 hertz. Actually, it is between 16,000 and 18,000, but to make it simple for you guys, examiner accepts that you understand that human ear can hear between 20 hertz and 20,000 hertz. So if frequency is less than 20 hertz, can we hear it? Answer is no. This is infrasonic. It is inferior sound. We cannot hear it. Infrasonic. Now, if 20 to 20,000 hertz, this is audible sound. Human ear can normally hear it. What if frequency is more than 20 kilohertz? 20 kilohertz means 20,000 hertz. That sound is also not hearable by the human ear, but that is known as ultrasound. So ultrasound means frequency above human audibility range. Infrasound means frequency below human audibility range. And audible sound means between 20 hertz and 20,000 hertz. Any questions?
No, sir.
No, sir.
Good. Ultrasound and its echo is used in medical science for sonogram and in navigation as sonar. So you must have heard sonogram. It is the result of ultrasound. So we send high frequency waves into the human body. They reflect from different surfaces. We know the speed of sound in every medium, so we can find out the exact distance of any particular layer from the skin. And on the basis of that, we can produce some kind of imagery or understanding. Now, this is what you should remember. Okay, this is, you should know them. You have to remember them. That speed of sound in vacuum is 0. Sound cannot go in vacuum. Speed of sound in air is 330 meters per second. Speed of sound in water is around 1500 meters per second. Speed of sound in steel is 5,000 to 6,000 meters per second. So you can consider it 5,000 meters per second. So this is what you have to remember. Other than these, one more speed that you have to remember is speed of light. Speed of light is 3.0 into 10 to the power 8 meters per second. Okay, so these are the things you need to remember, because examiner can simply ask, what is the speed of sound in air? What is speed of sound in water? And he can be just straightforward with this. That you don't have to, there's not data given that you can calculate it. You need to know it. Okay, there's not a kind of data that you can produce from your intelligence or by remembering some formula. This is something that you have to remember. Very few things are required to be remembered in O-levels and IGCSE, but this is one of them, that you need to remember that speed of sound in vacuum is 0. Speed of sound in air is 330 meters per second. Any number between 300 and 350 is acceptable by the examiner. 330 meters per second, then speed of sound in water is 1500 meters per second, and speed of sound in steel is 5,000 meters per second. Speed of light in vacuum or air is 3.0 into 10 to the power 8 meters per second. So these are things that you need to remember. measuring speed of sound. No. Number one, speed of sound outdoor. Method one. So these are two people, person A and person B. They are standing at a distance D. D must be between 100 and 200 meter. So this person either fires a smoke gun or smashes two wooden blocks together. So, or anything that can be heard and seen. Sound must be loud and short. So it is not like a continuous sound is produced. We produce a short sound, loud but short sound. This is what is done by person A. Person B B has a stopwatch. She measures, or she start the stopwatch and sees and stop the timer when hears the sound. So whatever they do, whether it is a smoke gun or it is a wooden blocks that have been clapped together very hard, um, the person B is supposed to start the stopwatch when he or she sees that thing happening, and they stop the timer when they hear the sound. Light almost reaches person B immediately. So, and sound take more time. This is because sound is slower than light. So light will reach the person B immediately. He will start the stopwatch, and sound will take some time. And when sound reaches the person B, he stops the stopwatch. Distance D can be measured using measuring tape. Then speed of sound will be distance divided by distance D divided by time on timer. So speed of sound will be distance over D. Any confusion?
No, sir.
Method this is a tall building in a deserted area. No, this is a building, and there are two people standing over here. This is B, this is A, and this is distance D. D should be between 100 and 200 meters per year. Similarly, person A produces a loud and short sound by firing a smoke gun or smashing two wooden blocks hard. 2. Person B starts the timer on stopwatch when hears the sound directly from source and stops the stopwatch timer when hears the echo. What is echo? Echo is this deflection of the sound. So sound goes, hits the building, and then comes back. So how many times sound has traveled distance d? In this case, sound has traveled distance d 2 times. Speed of sound will be 2 times distance of A and B from building divided by time shown on timer. So speed will be 2d over t. Okay? Confusion?
No, sir.
Good. No. One last method in a lab, measuring speed of sound in lab. This is a ruler. This is a microphone. This is a CRO. Now, this is a ruler. is mic 2. This is mic 1. So what we do is we produce a loud short sound. So sound will first go from which mic? Mic 1. Let's say this is position 1 on the ruler. This is position 2. So on CRO, what we are expected to see on CRO? On a CRO, we will observe okay. So what happens is first sound goes into microphone number 1. So microphone number 1 will send a pulse to the CRO and we will get the first pulse. This is mic 1. And then mic 2, the same sound then travels through mic number 2. So mic 2 also sends another pulse, that is mic 2. Actually, mic 1 will send first. Mic 2 will send data. On CRO, we can find the boxes from there to there. Uh, Distance between mics equals to P2 minus P1. Time taken for sound to move from P1 to P2 is observed and measured from CRO. Distance between pulses multiplied by time base equals to time taken. Speed of sound distance between P1 and P2 divided by time taken. So speed equals to D over T. So if you cannot go out for an experiment like this, then in lab you can use a CRO and a pair of mics to measure the speed of sound. Okay, now you should be doing past paper questions. I will share some past paper question in a short while, and we will do them tomorrow. Okay, see you people tomorrow.
Okay, sir. Allah Hafiz.